I've simplified all the terms. I still have two unknowns, right? The V1 and the V2 term. But what I did in part one of this video, when I solved for this expression using our x direction, we got V1 in terms of V2. So now what I can do is take this equation, which I labeled equation 3, and substitute all of this wherever I see a V1, which is right here, because V1 is equal to all of this. All right, so I rewrote the expression here to make some more space, but I did correct a small error. I had plus this term at the end, but it actually should be a minus. And the reason it should be a minus is because when we looked at this term for this ball moving in this direction, the y direction of its velocity is not a positive number because it's not moving up. Down is actually the negative direction. So I missed the negative term there, and that's what makes this negative. In fact, that's a common mistake for people, and maybe you can go back and pause the video and try to find where I made that mistake and see exactly what I'm referring to. But yeah, this has to be a negative term. So now what we're going to do is take that expression that I derived by looking in the x direction and just plugging that in for my V1 term here, because it says V1 is equal to this. And so all of that can go here. This becomes 0.85 equals 0.109. And then here I'm going to make the substitution. That's 11.323 minus 0.792 times V2. So all of that is equivalent to this V1 term. And then I'm going to do minus 0.123 V2. And that completes the expression. I've now substituted the previous equation into the new equation. And now what you're going to notice is I have two V2 terms, which means I can simplify all of this and solve for V2 and actually figure out how fast this ball is going after the pool ball hit it. And then once I know V2, I can plug it into my original equation here and solve for V1 to figure out how fast this ball is going after it got hit, or rather after it hit the other ball.